Lesson 1.4 is a lot of review. I just realized, should I have turned these lights down sooner? Or could you guys see okay?
I could see before, but now the notes are better.
Is that okay?
Yeah.
Okay, so lesson 1.4, we are talking about functions. Officially it says building functions from functions, combinations, compositions. We've talked about some of this. We'll talk about decomposing domain, a little bit of everything here. So let's go through some basics, and they are definitely some basics at the beginning. Combinations of functions. So right here is just kind of reminding us that for something like f plus x, if you're asked to find, not f plus x, f plus g of x, that is the same as doing f of x plus g of x. If you're asked to do f minus g of x, that's the same as doing f of x minus g of x. If you're asked to do fg of x, then you're doing f of x times g of x. And then, of course, if you're asked to do f over g of x, that's f of x divided by g of x. Nothing fancy there, just kind of a basic reminder about how functions work. So in example 1, they define f of x to be x squared, and g of x is the square root of x plus 1. First thing we're asked to find, f plus g of x. If I find f plus g of x, what am I going to do? Add the two. So that means I'm going to be adding x squared plus square root of x plus 1. Clean up. Can I clean that up any? That's an x squared and a square root. It goes as far as we can right there. Okay, that was f plus g. What about f minus g of x? Sound good? Instead of x squared plus square root of x plus 1, it's going to be x squared minus square root of x plus 1. Okay. What about fg of x? Okay. X squared times the square root of x plus 1. Can I clean that up any? Nah, not really. It's a x squared and a square root, so we're going to leave it as is. F over g of x. That means we're going to do x squared divided by the square root of x plus 1. And clean up. Okay, so here's the good news. On this type, because we're just kind of showing the combinations, the book actually lets us leave it like this. So we'll enjoy it while we can. Officially, though, what is the rule? Yeah, officially the rule is we can't leave a radical in the denominator. So normally we would have to rationalize. Do you remember how to rationalize this? Okay, if it's just a single square root in the denominator, you multiply by that square root. So we'd multiply by square root of x plus 1. What you do in the bottom, you do to the top. Okay? But again, enjoy it. They let us leave it like this, so we're going to go for it. Okay, composition of functions. I say composition of functions, that may not sound familiar. What about fog? Golf. Okay. We did fog and golf last year. Okay. You may or may not have done it in Algebra 1. I can't guarantee you did this in Algebra 1, but, okay. So, officially it's not fog, it's F composed with G of X. The shortcut, or the shorthand is to say fog. Okay, so remember this is a composition dot. It means F composed with G of X. But what this is going to become is F of G of X. Meaning you will plug the entire G of X function into F of X. So in this example, there's a new F of X defined as e to the X, and G of X is defined as square root of X. Let's start by finding what I call fog. What does fog mean? F of G of X. Now, by all means, if you can just jump to the answer, go for it. But the idea is G of X is going to go into F of X, yes? What is G of X? G of X is square root of X. So you can, as an intermediate step if you want, write this as F of square root of X. Some of you may not want this, and that's fine. But what this is showing is that now I'm going to take square root of X and plug it into F. Every place I see an X, it becomes square root of X. So what is F? E to the X. So when I plug square root of X in, it's going to become e to the square root of X. Does that sound a little familiar? Maybe you'll be better at them this year then. Just because you worked at them last year doesn't mean you're doomed this year. There you go, see? Okay, that was fog. We're also being asked to find Goth. So Goth, G composed with F of X. Or, if I write this out, it's G of F of X. So what does this mean? Okay, so F has to go into G. What is F? E to the X. So E to the X has to go into G. If you want to write it as G of E to the X, you can. If that confuses you, then forget what I'm writing, I guess. Okay, and I don't know if it helps or if it hinders. I think it might depend on the person, too. Okay, so E to the X has to go into G now. So G says square root of X. So instead of square root of X, we're going to say square root of E to the X. Yes, because E of X here replaces where X was. Yeah, E to whatever F was, which was E to the X, that now replaces this X value. Okay? I will tell you, as you move forward, we do use them more. And I'm trying to think how much we use them in pre-cal. They definitely come up in calc. So being able to do something like F of, G of E to the X. So, well, it's never too late to make friends with them.
Well, but it's just you're just kind of copying and pasting.
Yeah.
I thought Jake was raising his hand for me. Okay. Are we a little bit better back there?
I think so.
Okay.
I think it's just where all the numbers are coming
Okay, well, we're going to practice some more on this next one, too. So, okay. Now we're going to talk about finding the domain of composition. So, it's still practicing doing our compositions. So, doing fog or Goff, but then talking about the domain of it. So, as I said, we still get to practice. We have a new f and g, so we get to practice differently here. F is now x squared minus 1. G is square root of x. Find the domains of fog and Goff. Before you can find the domain, you kind of need to find what fog is, what Goff is. So let's practice here. The domain part?
Yeah.
Not necessarily. I don't remember. Okay, fog. So what's fog mean? F of g of x. So that means I'm going to take whatever g is and plug it into f. So what is g? Square root of x. And I'm going to plug it into the f. And there it says to do whatever it is squared minus 1. So instead of x squared, I'm going to square root of x squared. So fog is going to be square root of x squared minus 1. Are we okay with that? I took the square root of x and I put it in place of this x right here. So I then squared that value. Now, okay, I already heard someone out there say square root of x squared is x. And if my whole job here was to simplify, I would simplify and say it is x minus 1. Now, we are being asked to find the domain, though. And if we're talking domain, there's a reason I'm stopping there. If this simplifies to be x minus 1, are there any limits on what I can put in for x? No, you can subtract 1 from anything. So there's no limits. However, was this just x minus 1? It came from square root of x. Right. If this is square root of x squared, what can you not put in here under a square root? You can't put in negatives. Yeah, so if it can't be negative, that means it has to be positive. So x greater than or equal to 0, all because of the square root. How do I write that in interval notation? Okay, 0 to infinity, and 0 has a bracket. Are we okay with writing that 0 to infinity, or do you need a number line to think it through? I mean, the idea here is if you need a number line, it was x greater than or equal to 0, yes? So that'd be everything to the right of 0. Greater than or equal to would mean a bracket. So there's a number line if you need that to help you. A lot of you probably don't need that anymore, but just in case. Okay, let's try Goff. What does Goff mean? It's G composed with f of x, which is written as G of f of x. Okay, so f gets plugged into G, yes.
X squared minus 1.
Okay, so f, which is x squared minus 1, goes into G wherever the x is. It was square root of x, so now it's going to be square root of x squared minus 1. Now, again, this is where, well, first of all, realize you can't simplify that. Okay? You cannot take a square root of a sum or a difference. You can take a square root of x squared, you can take a square root of 1, but we can't do a square root of x squared minus 1. Now, what about the domain this time? What do you know about the value under the radical? Almost.
No, it can't always be positive.
So, okay, whatever you put in for x, you square it, it's going to become positive, yes? But then you have to subtract 1.
Yeah, so you start at 1 and then you subtract 1 and it's 0. So if it's 1 squared, it's still 1 and then minus 1.
Okay, so you can put 1 in there. You can put bigger numbers in there. Now, can you put 0 in there? No, because 0 minus 1 would be negative. Okay, so just like, here's what I'm going to say. Just like this last one, here we took whatever was under the radical and said it had to be positive, yes? So I said x greater than or equal to 1. You can do the same thing here. You can use the idea that, okay, we have to think about, and you guys are heading the right track, x squared minus 1 has to be greater than or equal to 0. If you add 1, whoops, that means x squared has to be greater than or equal to 1. Now, officially, you take the square root, right? And we haven't really talked about this. When you square root x squared, you get x. When you square root 1, you get positive 1 or negative 1. How this works out to be is x greater than or equal to 1. Notice it's greater than. So it's an or, and then you flip it for the other one. X less than or equal to negative 1. And think about if that makes sense. Does this make sense? Okay, we just talked about has to be numbers bigger than 1, yes? 1 works, 2 works, so on and so forth. That means those negative equivalencies could work, yes? Negative 1, negative 2, negative 3, because when you square them, they become positive. What can't work? These little small numbers, these fractions between 1 and negative 1. Because when you square them, you'll get positive, but there'll be a number less than 1. So when you subtract, you'll get a negative. Okay? Can you write this in interval notation? Okay, negative infinity to negative 1, union 1 to infinity. And they are brackets, yes. Okay. That is a good stopping point. That honestly doesn't leave us too much for tomorrow either. We have to talk about decomposing, which isn't too bad. It's just a matter of seeing it. We do have a word problem on the back, which is a good thing to run through. So, here's my plan. Tomorrow, finish the notes. And then you will essentially have work time. Now, the work time will be twofold work time. One thing to work on is this assignment. However, the other thing I'm also going to go ahead and hand out tomorrow is the review worksheet for the quiz. Now, if you want to go ahead and get started on lesson 1-4 homework, I would encourage that because you could do parts of this, yes? You can't necessarily do all of it, but you could do a decent part of it. So go ahead and get started on the homework. You'll be a little bit of a step ahead. And then, as I said, tomorrow you'll have some work time and also the worksheet. This homework will not be due until Friday. I mean, I could almost make it due by the end of the period tomorrow if you could get started on it tonight, but nah. So you pick and choose. When do you have more free time in your schedule this week, right? And then the worksheet, when I hand that to you, you guys know that the quiz will be Tuesday, so you'll turn in the worksheet on Tuesday.